Welcome back everyone and good day. Today this will be our fifth video since, as discussed earlier, this entire power system here will have 8 videos as we divided this entire system by 8 sections. So far we have done 4 videos already. We called it, we divided it by parts. So this section here, we prepared a separate video and we called it part 1 of 8. This is for the bus coupler, and this outgoing feeder for this 11 kV switchgear of building A, and the incomers of 11 kV for 11 kV switchgear of building F. This is a separate section, and we prepared already a video dedicated for this relay setting calculation, and we called it part 2 of 8 video. So this bus coupler here for the 11 kV switchgear of the building A, this is our part 3, and we have also a separate video for this one already posted on our channel. And the 2 incomers here for the 11 kV switchgear of building A, this is our recent video prior to our 5th video. Right now this is our 5th video. So this is the part 4, and this is considered as our video number 4. For our video right now, we will be discussing this crosstie connection between building A 11 kV switchgear and building B 11 kV switchgear. So we have here in your screen 2 types, actually 4 types of relays. We have here 51, 51N, 67, and 67N. So these are in both directions, going to the right and going to the left. It depends upon on which building or feeders are feeding on the system. So although I have discussed to you this, how we assign here our time setting, I will discuss it again. I discussed this one earlier on my video number 1 and video number 2. So here our on how we assign our time setting, we have 2 conditions. It's either the power source is taken from building B or at building A. First condition, if the power is taken from building B, and in a worst condition, the power source is taken on the right side of our 11 kV switchgear bus on building B. For example, the power supply, for worst condition, the power supply is available only on this incoming feeder. So meaning this is out, and all building A also income power source are not available. This is out and this is out. So the power is flowing from here going to building F down. So how we assign our time setting here from building F on our bus coupler, our time setting here, the pickup value is 0.35 second. So in this calculation, our CTI or coordination time interval is 250 milliseconds or 0.25 seconds. So we started here for our bus coupler as 0.35 our pickup time is 0.35 second. Next, this outgoing feeder here have the same relay setting from the building F11 switch gear, 11 kV switch gear incomers. So from here, our pickup time, these 4 relays from here, our pickup time is being assigned at 0.6 seconds. So going to that way, since our source is coming from this building B, okay, on this side, so our bus coupler here, our bus coupler here is being assigned as 0.85 second, the pickup time. Okay, so here our subject for discussion. By the way, this the title of our subject for discussion for this session is protection relay setting calculation for this cross-tie feeder. So it's the same setting, relay setting, both this relay which is connected to building A switchgear as cross-tie feeder, and also the relay for building B as cross-tie feeder. So in this side, our pickup time is 1.1 second because the power is coming from here and the direction is going to the left. So we assign here 1.1 second because it has to be coordinated to this relay from here, which is being assigned as 0.85 second. Next, our bus coupler, the directional overcurrent relay, the time pickup is 1.35 seconds to coordinate with our cross-tie feeders, which is 1.1 second. Okay, the uppermost, which is from the incoming feeder, okay, the only available feeder for our condition 1, this relay is being set, the time setting is 1.6 seconds. So this is how we set, this is the first condition on how we set our time setting. Okay, the second condition, if in case the power, in a worst case scenario, we have only one available at building A. So it's either, for example, the available only on the building A in this incoming feeder, and all these 3 and also this one are not available. So meaning here in our cross-tie feeder, if the power is only available at building A 11 kV switchgear, the direction of the power is going this way. That's why from here our time setting is 0.6 seconds. Why? Because from here we have 1.1 second, right? This bus coupler is being set at 0.85 seconds. So therefore this one has to set at 0.6 seconds. So since this one is not available, the next relay downstream will be this. So our time setting will be at 0.35 seconds. So here downstream will not be changed since our this second condition, the power source is taken from building A. So this we can check this cross-tie feeder. We can check it from our actual single line diagram. The location of our cross-tie feeder for building A is this area here. Building A, main 11 kV switchgear, and is being connected on the building B from this feeder also here. So building A and building B are interconnected to each other, so that our system will have a robust and stable power source. Because why is this very robust? Because each of this building has two power source or two incoming feeders. So the total, if you check from here, going to building F, we have a total of 4 different power sources. So it's the design was designed to have a robust connection. So we go back to our summary of our relay setting for phase phase overcurrent relay and our directional overcurrent relay. So we have this information. Then now we're going to discuss how we got these settings from here. Okay, so let's open now our calculation document. So here it is mentioned that this is for the cross tie between building A and building B. By the way, in normal condition, this cross tie, this is normally open, this one, and the other cross tie is normally closed. Okay, so same, our relay is from GE F60 and Schneider Electric Maycom P143. Our CT ratio is 2500 is to 1 ampere. Bardeen S10 VA class 5P20. Our PT ratio is 11,000 into 110 volts. Our rated current of the our 11 kV minimum line to line fault is 8,406 ampere. Our 11 kV minimum line to ground fault is 409 ampere. Okay, so right now we will have some relays. Okay, we will going to calculate the relay setting for relay 51 for the phase overcurrent protection, and also for the directional phase overcurrent relay. For the directional phase overcurrent relay, by the way, this relay 51, this is only assigned for the first threshold. Our second threshold will be captured by directional phase overcurrent protection, or the ANSI 67, and the same also for our third threshold. So our second threshold, the time is 0.6, the pickup time is 0.6 second. Our third threshold, the pickup time is 1.1 second. Our earthfall protection is also directional. We have here first threshold, and we have two threshold here, and we have for the voltage protection, we have for the over voltage and the under voltage. So let's discuss first on our relay 51 setting. So we have only one threshold, and we call it first threshold. So this threshold is being set at 120% of the rated CT rating, which is around 2500 amperes. So multiply by 1.2. That's why our current pickup setting here is 3000 ampere, or at 1.2 per unit. Our time dial multiplier here is being set at 0.33. Our inverse time curve for our 51 relay is IEEE very inverse. So this is the equation on how we got our total dial multiplier, and these are the constant values from our IEEE standard for A, for B, and for P. So we'll just substitute these values from here and this P and B here. On our time, for this phase overcurrent protection, we're going to use here, or for our first threshold is the pickup time is 1.1 second. So substituting all this data from here, our constant values and our line-to-line fault, on also our pickup value, our calculated time dial multiplier is 0.33. Next threshold, the second threshold, we are going to use our directional phase overcurrent protection. This threshold is being set at 100% of downstream threshold protection setting. So, what is our downstream from here? The downstream from here is being considered is the 4080 ampere. Meaning, let's open this. We are considering the 4080 ampere, this one. So we are considering, because we are from here, right? So we are considering this 4080 ampere for our second threshold. So this has been calculated based on our first video, which is the part 1 of 8 videos. So that is our second threshold. So our second threshold setting, after multiplying this 105% to 4080, we have here 4300 ampere, or at 1.72 per unit. So we'll just multiply this 4300 ampere by the relay, the CT ratio, which is 1/2500. So that's why we have this 1.72 per unit. Meaning, this is the side detection at building B. The side detection at building B, we go back from here. This is our building B. This is this relay from here, or this relay from here. 0.6 seconds. 0.6 second. Okay. Next is being set with a definite time at 0.6 second. Our third threshold is also being set at 105% downstream protection setting at 4525 ampere. Okay, so where we can find this 4525 ampere, let's go back here. Now we are on this setting from this bus coupler from here, this 4525 ampere, this one. Okay, so the outcome, the result after multiplying this given value here by 105%, we have here 4752 ampere, or our third threshold, the current pickup is 4750 ampere at 1.9 per unit. So the side detection here is coming from this building A. So this building A, this is the side protection. This side from here. Okay, so this is for the third threshold and this is for the second threshold. So with a definite time set at 1.1 second. So this is for the overcurrent protection. So for the overcurrent protection, for the phase element, the first threshold, will just review. The first threshold is from 51 relay. Our second and third threshold, we are going to use our directional phase overcurrent relay. So for our airflow protection, we will going to use directional airflow protection. So we have two thresholds. Our first threshold will be 12.2% of the rated current of the city. So we have here 0.122 times the 2,500. So we have here 302.5. This is our first threshold earth fault protection pickup at 0.122 per unit. So with a definite time set at 0.6 seconds. So the pickup side detection is at this building B, at this side. Next, the second threshold will be also 12.4% of the rated current of the city, which is 0.124 times 2,500 is the rated current city rating of the city. So our second threshold pickup for our Ilford protection is 310 ampere at 0.124 per unit. So the side detection will be on the building A. So this side from here, and with the definite time set at 1.1 second. So next relay will be for our phase over voltage and phase under voltage protection. So on our phase over voltage protection, this is the same setting for all the entire power system. For the over voltage protection, our threshold here is being set at 100% of the rated voltage, which is the rated voltage is 11 kV. Our peak of value here is 12,650 volts at 1.15 per unit, with a definite time set at 2.25 seconds. So this 2.25 seconds, this is the same time setting. We are here on this level. So this is the same time setting of this 1 point. It's open from here. This is for the bus coupler. Okay, so for this bus coupler, which is, if you open the previous calculation, we have this being set at T 2.25 seconds because they have the same level. So it is being set at 2.25 seconds. And on our phase under voltage protection, our threshold is 80% of the rated voltage. So we just multiply the 80% by our rated voltage, which is 11 kV. So our under voltage pickup value from here is 8,800 volts at 0.80 per unit. So with a definite time set at 3.75 seconds. So the same time setting on our bus coupler from here, from this area. Okay, thanks for watching.